What's up guys, it's Iman Fiaz and today's video is on isomerism and carbonyl compounds. So the definition of optical isomerism, a type of stereoisomerism, and stereoisomerism when the atoms have the same structural formula, but atoms are arranged differently in space. Enantiomers are mirror images and they can't be superimposed. Superimposed is when you put one thing on top of another and they match up completely. Therefore, if they're superimposed, it's achiral. Therefore, it does not show no optical isomerism. Should say no optical isomerism. Normal light. Well, normal light vibrates in all directions, but plane polarized light only vibrates in one direction. Optical isomers are optically active. Enantiomers are optically active. They rotate plane polarized light. One enantiomer rotates in a clockwise direction, other rotates in anti-clockwise direction. Racemate, the definition of racemate, or it could be seen in exams as a racemic mixture, contains equal quantities of each enantiomer of an optically active compound. Racemates show no optical activity because the two enantiomers cancel each other's light rotating effect. What do chemists often do then? They react two achiral things together and they get a racemic mixture of a chiral product. As when two molecules react together, we get an equal chance of forming each of the enantiomers. The products of reaction at the carbonyl groups of aldehyde unsymmetrical ketones are enantiomers present as racemic mixtures. Aldehyde ketones are carbonyl compounds and they contain a carbonyl functional group. Aldehydes have the carbonyl functional group at the end of the carbon chain. At the end of the chain, ketones have it in the middle of the carbon chain. Both contain a carbonyl functional group. Ketones have a number though to show the carbon number the carbonyl group is on. So in the example here, 1, 2, 3, 4, 5, 6, 7 carbons. So it's not going to be methane, ethane, propane, butane, pentane, hexane, 7 carbons, so it's going to be heptane, right? Now, I'm not going to start from here, 1, 2, 3, 4, 5, 6, so heptane 6 oh no. I can start from here, and I want to get the smallest number, so heptane 2 on. And I'm showing which carbon the carbonyl group is on. That's not what I wanted. So, tolerance region, a colorless solution of silver nitrate dissolved in aqueous ammonia. When it's heated in a test tube with aldehyde, Ag plus ions in tolerance region are reduced to Ag atoms and silver mirror form. So tolerance region, a colorless solution of silver nitrate dissolved in aqueous ammonia. Failing solution, a blue solution of copper 2 ions dissolved in sodium hydroxide. If heated with aldehyde, copper 2 ions are reduced to a brick red precipitate of copper 1 oxide. These two are just practical skills you just have to memorize. Reducing an aldehyde to a primary alcohol. So you got an aldehyde, RC-H plus 2 H's. The hydrogens come from reducing agent to form your primary alcohol, R-CH2-OH, or reducing a ketone to secondary alcohol, RC-R- plus 2 H's to form RCHOH-R-. We use sodium borohydride dissolved in water with methanol, and that's the reducing agent when reducing an aldehyde to primary alcohol, reducing a ketone to secondary alcohol. RC-R- plus 2 H's, RCHR-OH. Nucleophilic addition mechanism. So in this case, reducing an aldehyde to primary alcohol. So, lone pair of electron, the H minus, attacks partial bonds of carbon, middle of the C double bond O, the oxygen delta negative, transfer electrons to there. Then you get this oxygen lone pair of electron negative charge, bonds to the H plus, and you get that. Just remember, the hydrogen is negatively charged and it has a lone pair of electrons. That's the most confusing thing in my opinion. The H- sign acts as a nucleophile. It comes from the reducing agent sodium borohydride dissolved in water with methanol and adds onto the partially positive carbon atom. Carboxyl group contains a carbonyl group and a hydroxyl group. That's just a key fact. Carboxyl group always at the end of the molecule, and my naming is more vital than other functional groups for carboxylic acid. So carboxylic acids are weak acids, and in water they partially dissociate into a carboxylic ion and H plus ion. So you can see here RC-OH, carboxylic acid, reversible reaction RC-O minus, carboxylic ion plus H plus. Or the two equations, 2CH3COOH aqueous plus Na2 CO3 solid to form 2CH3CO aqueous plus H2O liquid plus CO2 gaseous. Replacing the hydrogen with a solid, forming CO2 and forming water. CH3COOH aqueous plus Na HCO3 solid to form CH3CO and aqueous plus H2O liquid plus CO2 gaseous. Carboxylic acid plus metal carbonate, which contains a CO3 ion, to form a salt plus CO2 plus H2O. And the key factor is that carbon dioxide fizzes out of the solution. Esters, organic compounds containing a COO group. Definition of esterification reaction: heating of carboxylic acid with an alcohol in presence of a strong acid catalyst, in this case concentrated H+4. So RC1OH carboxylic acid plus R-O-H, your alcohol. Reversible reaction H plus reflux to form the ester. And what happens is basically this oxygen comes from the alcohol. So what happens is this OH and this hydrogen forms H2O, and this O and R just bonds here. So yeah, so here that leaves us water, then that bonds there. Oxygen comes from alcohol. Also, condensation reactions releases water. Naming ester: the first part comes from the alcohol, second part comes from the carboxylic acid, and the name is written opposite way around from the formula, and that's very important. State 4 uses of esters: food flavorings, perfumes, solvents, and plasticizers. Food flavorings, perfumes, solvents, and plasticizers. State 4 advantages of ethanol anhydride over ethanol chloride: cheaper than ethanol chloride, safer to use than ethanol chloride, less corrosive, reacts more slowly with water than ethanol chloride, does not produce dangerous hydrogen HCl fumes. Fatty acids are long chain carboxylic acids. They combine with glycerol to make esters. Esters of glycerol are fats and oils. Describing the structure of animal fats: they have saturated hydrocarbon chains which fit together, increasing the van der Waals forces between them, therefore requires high temperature to melt them, therefore is solid at room temperature. Whereas structure of vegetable oils, unsaturated hydrocarbon chains, contains double bonds, therefore meaning the chains are bent, they don't fit well together, decreasing the van der Waals forces, so it's a liquid at room temperature and requires little energy to melt them. Acid anhydride is made from two identical carboxylic acid molecules. Acid anhydride is made from two identical carboxylic acid molecules. The reactions of acid anhydride with water, alcohol, ammonia, and amines reaction are less vigorous, and we get a carboxylic acid formed instead of HCl. Remember, it does not produce HCl formed. We get a carboxylic acid, and it's less vigorous. How is aspirin, which is an ester, made? By reacting salicylic acid with ethanoic anhydride / ethanol chloride. How is aspirin made? By reacting salicylic acid with ethanoic anhydride / ethanol chloride. Now, obviously, there are a lot of mechanisms I haven't included. Nucleophilic addition, elimination mechanism, all the reactions of ethanol chloride, acyl chloride with water, alcohol, ammonia, amines. That's because of my mechanism video. I've already got those, so I was just like, I just posted into that section instead of doing on this video. So all those mechanisms will be posted on my mechanisms playlist.